The Immune System by Max Damon and Sandy R. What is the immune system? Well, to start, the immune system is, in short, a complex system of proteins and cells that are dedicated to defending the body from harmful bacteria, chemicals, or fungus, called antigens, or any substance that may cause the body harm and thus induce an immune response. The immune system uses a complex mix of methods to identify and defend against these antigens, coordinating multiple proteins and cell parts to identify, mark, and eliminate different antigens. Some of the basics of the immune system include white blood cells, which are made in the bone marrow and released through the bloodstream to find potentially harmful substances and launch an immune response. White blood cells themselves are a part of the lymphatic system and contain various types of immune cells. Antibodies are part of the immune response and help attack problematic microbes found in the body by identifying them as antigens and marking them for destruction by the body. The actual destruction of these antigens can be carried out by various other chemicals and proteins in the immune system. Now, a topic I'd like to focus on is autoimmunity. A very disturbing malfunction that can occur in the immune system is something called autoimmunity. This is when the immune system causes damage to your own body, and unfortunately it can happen in quite a few ways. Sometimes the immune system will end up targeting itself as if it's an antigen, where the bodies mark your own cells for destruction. In this case, antibodies are called autoimmune antibodies, or autoantibodies for short. In other cases, the damage caused by the body can be a case of collateral damage, where the immune system can, for example, overperform and cause inflammation or clotting. Let's look at a very timely example of autoimmunity causing severe damage in patients of COVID-19. Now, autoimmunity is not unique to COVID, as it appears in various other conditions, such as type 1 diabetes and multiple sclerosis. Because COVID-19 largely affects the lungs, these cases of COVID result in autoimmunity causing scarring of the lungs, or pulmonary fibrosis. Normally, some extent of damage is always expected when someone has COVID-19. But the triggering of autoimmunity was discovered after the autopsies of several COVID patients found a large disparity between the intensity of the virus and the amount of damage in the same set of lungs. Now, the most fascinating and disturbing part of the discovery is that it's the autoimmunity that's actually doing most of the work in the deaths of these patients. The people studied in these autopsies were killed more by their own immune systems than by the disease. A study was done to compare a control group and 140 COVID patients, and it was found that these problematic antibodies appeared in about 50% of COVID patients. For reference, less than 15% of healthy people had autoimmune antibodies. Another study of 1,000 patients showed that 10% developed antibodies that blocked a protein meant to protect against pathogens. However, it should be noted that this has not yet had its follow-up study to compare it to uninfected people. In 20% of patients from that study, the amount of autoantibodies increased as COVID progressed. Autoimmune antibodies can take weeks to build, which is theorized as a potential reason for COVID's delayed but intense effects. All in all, the autoimmune antibodies that we're talking about here are not distinct in any way from those provoked by any other source, but are at the moment very clearly correlated with the progression of COVID-19. Now, let's go back to what I had said earlier about how there's different ways that the body can end up harming itself. I had mentioned that sometimes it's more a case of collateral damage as opposed to a targeted attack. One example of this would be a phenomenon known as a cytokine storm. Cytokines are proteins that respond to various issues, such as inflammation or even signaling for cancerous cells to die. They're an important part of the immune response, but there are certain conditions that can cause them to overact and cause problems. COVID-19 can also provide us with an example of this. Once again, a cytokine storm isn't unique to COVID-19, but it is frequently provoked by it. In this case, it causes a cytokine storm in the lungs. In the case of COVID, the cytokine will try to assess damage in the lungs, such as the scarring mentioned earlier, but end up over-responding and sending far too much of it, hence why it's called a storm. This causes excessive inflammation and even clotting that can severely damage or even kill someone. The reason this becomes so severe is because the attention the inflammation draws to the point of injury creates a positive feedback loop, continually causing more and more immune response cells to come to the site, and in turn cause more damage with excessive inflammation and clotting. Another example would be a case in 2006. While testing a drug called TGN 1412, all 6 volunteer subjects had a cytokine storm. This was entirely unexpected by the researchers. It was suspected that the stimulation of memory T cells by the drug caused the cytokine storm. Memory T cells are cells that respond to antigens using past encounters with that specific antigen and provoke a significantly more intense response. By overstimulating these memory T cells, they overacted and began to damage the volunteers. What makes this case so terrifying is how rapidly it occurred. Within 10 minutes, the inflammation was reaching critical damage and causing multiple organ failure. These are all incredibly concerning and interesting cases of the immune system malfunctioning. But I'd like to pass it over to my partner to explain something that a lot of you might be a bit more familiar with.
What are allergies? An allergy is a type of immune reaction. Usually, the immune system reacts to outside organisms by creating antibodies. The reaction between the antibodies and the antigen create a chemical reaction that is designed to protect the body. However, sometimes the chemical reaction is triggered by pollen dust or animal fur, and this causes the body to react in a bad way against them. This is what we call an allergy. Most allergic reactions are caused by hemoglobin type E, or IgE, that binds to allergens. Allergy symptoms could be mild to life-threatening. Some examples are rashes, swelling, itchiness, wheezing, and watery eyes, and so on. Allergic reaction steps. Step 1, hemoglobin type E binds with allergens. Step 2, hemoglobin type E released from mast cells. They release granules that contain histamine. Step 3, histamine and other chemicals are released, and these create an allergic reaction. The two main types of allergic reactions. Immediate hypersensitivity reactions, which are mostly caused by mast cells mediated. These usually occur in minutes of contact with the allergen. Inhaling or ingesting allergens would most likely cause an immediate hypersensitivity reaction. Examples would be eating shellfish or breathing specific pollens. Delayed hypersensitivity reactions, which are caused by T cells, a type of white blood cells that occur hours to days after exposure to the allergen. Examples would be being in contact with poisonous plants or an allergic skin test to see what you are allergic to. Anaphylaxis. If you have anaphylaxis allergy, it could be life-threatening. This is a severe reaction where an over-release of a chemical puts the person into a shock. Some examples are trouble breathing, tightness of the throat, abdominal pain, nausea, fainting, low blood sugar, and cardiac arrest. Some severe anaphylaxis allergies are so severe that even if you walk into a room and smell peanuts, you can have an allergic reaction. The EpiPen, or more formally known as an epinephrine autoinjector, is a medicine that could stop the reaction if used fast enough. Treatments and preventions. Antihistamines stop the histamine receptors, reducing the effect of histamine released by mast cells during an allergic reaction. Some examples of antihistamines are Benadryl, chlorotrimethoprim, Claritin, Dimetane, and Zyrtec. People take a skin test called the skin prick test to know what they are allergic to make sure they can be safe and stay away from their allergies. The end.